All right. So now that we've kind of had a really intense warm up with Postgres and timescale, let's continue. So next up, uh, I'm going to be sharing a little bit of knowledge with you guys. So my name is Artūrs Lontons. I'm a technical support engineer at Zabbix, and I am going to talk about. Let me share my screen. So hopefully you can see it now. I will be talking about tuning of Postgres for Zabbix. We'll be taking a look at this in two ways. First, we'll kind of take a look at the initial Zabbix installation. I will also show you, this is the workshop part, so I'm going to show you installing Zabbix on Postgres live. So I'm going to be dragging screens here and there, left and right. Yes, by the way, don't forget, there will be Q&A session at the very end also. So if you have any questions, maybe to all of the previous presenters, then feel free to throw them in. And yeah, I will be dragging my screens left and right, command line, presentation, and so on. So bear with me over here. And first we'll begin with, like I said, installing Zabbix with Postgres from scratch. I will be commenting on that whole process, kind of common pitfalls, things that maybe are not as clear as they should be, and some things that people commonly miss. And then we'll talk about kind of the basics of Postgres tuning and actually how Zabbix internal processes interact with Postgres settings. This is actually true for every database backend, but today we'll be taking a look at specifically Postgres and what you need to take into account on a very fresh install, what you need to tweak, because defaults, actually, you don't want to go with defaults pretty much on any database backend out there, and Postgres is no exception to that. It needs to be tweaked and tuned, otherwise, eventually, as you scale up, you will encounter some issues. So let's begin. So first off, let's talk about configuring Zabbix. And over here, we will be covering a couple of different parameters. I will briefly go through them, and then I will configure them myself during the live install. So this is after we have installed Zabbix. We have a couple of basic parameters that all of you are probably familiar with. First off, we have DB host, which is kind of the first pitfall. I remember first time I kind of installed Zabbix with Postgres, I was stuck here for a good 30 minutes. Because actually, by default, you will have, I think, no value over here, or localhost or something like that. Yeah, it will use localhost by default. Read this here line. If set to localhost, it will use the socket. We're using socket communication for MySQL. So we need to add the DB host is equal to an empty string. Otherwise, you will see connection errors as you try and start up your Zabbix server. So this is a very, very common thing, but you have to be careful with it because it can cost you some extra time until you figure this out. So it's pre-configured with localhost, but you need to leave this as an empty string in the Zabbix server config file. Next is quite simple. We specify the DB name. We specify the schema. By default, this will be commented out, which will also actually apply the public schema, or you can specify it manually, just so you know, for transparency, that maybe when new admins come in that are not familiar with Zabbix, they will realize that, yeah, you're actually using public as your schema. If we aren't sure what kind of schema we are using, we can log into our Postgres instance and do a list of schemas. And then by using /DT, we can take a look at which schemas do our tables belong to. We can see I'm using public here. Once we are done with this, we will specify the username and the password for our Zabbix user, self-explanatory. Then we will specify the database port. Once again, I tried plugging it in manually, 5432, and also plugging it in, just leaving it empty, plugging in an empty value. So it will work either as a commented out parameter, as an empty value, or you can just specify the port manually. Once again, I prefer specifying it just manually, 5432 inside. If we wish to change the port on which the Postgres server listens, we need to open the config file, and we can change the port over here if your security policies maybe restrict you in one way or another. Next up, something once again that we'll encounter in a moment and deal with. But actually, before we do this, before we get to this here error message, let's try and get the server running. I think that'll be a good idea. This is a good point where we can do that. So what I'm going to do, I'm going to drag my browser over here just so you know that I'm not cheating. I'm going to be copying my commands from this here download page. So we are installing Zabbix version 5.2 on CentOS actually, CentOS 8 with PostgreSQL Backend and Apache Web Server. And what I'm going to be doing, just to show you how simple it actually is to set up Zabbix with Postgres, I will just be copying these commands. Okay, just follow me step by step. You'll see that I'm not diverging, at least initially. Once I have it configured, I will do some kind of, once I have it installed, I will do some additional configuration. But the install process itself is going to be like this. So I will drag this to my second screen. And now let me, and now I will drag the terminal over here. So let's drag the terminal. There we go. So that's my CentOS 8 instance. OS release. See, it's CentOS 8. Postgres is already installed with the defaults, which are not optimal, and we'll be talking about why they're not optimal. Maybe I'll break my instance at some point also. Of course, on purpose, but I might. So there it is. And let's start with installing Zabbix. First step, very simple. I will just install the Zabbix repository. So there we go. Feel free to follow me. That's why it's a workshop. I will also keep an eye out on the Q&A. Yeah, Q&A, and yeah, I recommend using Q&A if you guys have any questions, because it's kind of hard for me to keep an eye on both the chat and the Q&A. So we have added our repo. Great. And now, since this is a fresh install, I can do DNF clean, although it's kind of optional. It's a completely fresh VM. But let's just clean those DNF caches. And then let's install all of our components. Once again, I am copying and pasting this from the download page. So let's go. So we're installing server for PostgreSQL. Once again, why do we have PostgreSQL over here? Because each of these server packages, MySQL, Postgres, Oracle, it under the hood in the source code, it uses different queries for each of the DB backends. So that's why when you're installing MySQL, you will have Zabbix Server MySQL. When you're installing Oracle, you'll have Zabbix Server Oracle. And over here, we have Zabbix Server PostgreSQL. Same for the web frontend. Web frontend, of course, also talks to the database and has its own set of queries depending on what kind of database backend you are using. Then we are installing configuration for the Apache database backend, and we are also installing the agent. Maybe we want to install agent 2 if you wish, or agent 1. It's completely up to you. So let's get going. I should have passed a yes, but fine, we'll just agree to things manually. So yes, I do agree to all of this. Yes, this seems also fine. I know what I'm installing. And yeah, we do keep them questions coming in. If I'm unable to answer them, then we will have kind of general Q&A session at the end where we can cover some of your questions, and some of my colleagues and hopefully some people from the Postgres professional side will also be sticking with us. So we have installed Zabbix Server, Zabbix Web, and Zabbix Agent, also the configuration for Zabbix Web. Now, next step is to create a Postgres user. So let's create it. A colleague of mine just congratulated me that It's brave to do a live demo during Meetup because things can go wrong. Maybe they will, maybe they won't, we'll see. So I have created my Postgres user. Permission denied is because we are currently located in the root directory, and this here user that we just sudoed into doesn't have access to it. Perfectly fine, nothing to do with Postgres or Zabbix. So we have created our user. Then next up, let's just follow the download page. We will create our database, our Zabbix database. Once again, the error over here is because we are sudoing into a Postgres user, and we're currently inside the root directory, to which has no access. Perfectly fine. Okay, we have our user ready. We have our database ready. These two commands. So username Zabbix, you'll see what kind of password I used in a moment. And we've also created the Zabbix database. Now, once again, copy and paste the command to import the data into the empty database that we just created. Remember, with Zabbix, when we are installing it from scratch, we cannot have a completely empty database. We need to import the initial configuration. So zcat, let's point it towards the archive with the config and import it into our Zabbix database. And there we go. This looks like good news. Things are being created. That means that the credentials are working just fine. Everything looks good and committed and great. All right. Next step, and let's try breaking things a little bit right now. Let's see how that goes. We need to open our server config, zabbixserver.conf, and let me show you what took me so long. So, of course, with maybe MySQL or MariaDB or whatever you use, you just use that. Hey, you plug in the password, DB password Zabbix, DB user Zabbix. There we go. Database schema, we're using public. Database name Zabbix. Database host localhost. Sure, yeah, looks good. Let's see. Systemctl start Zabbix. Let me zoom in a bit. Zabbix server. Started it. Let me check the logs. Var log Zabbix, Zabbix server log. And I cannot connect to the database. Why is that? And this is where you can get stuck for 30 minutes. This is what I mentioned. You go back to the server config and you just carefully read through it this time. DB host, localhost. This is used for MySQL sockets. What we need to do is we need to specify it like so. So empty. And let me try and restart it. Let me try and restart the server. Restart Zabbix server, and let's tail the log. And boom, magic. It's working. So you have to be really, really careful with this. It's a simple thing. It's a simple note that you may forget, but you have to be careful with it. This can, like I said, can hinder you by quite a bit. All right, so we have the server going. Just do a tailf var log Zabbix server log. Yep. Haven't started the agent yet, so we're seeing these error messages. Once again, perfectly fine. I'm expecting this to happen. Now let's move on. Let's move on with our download page. Let's see, there it is. So I have the server going on. Yep, I will start all of the other processes. I will enable them. Started and started. SC Linux is disabled on this machine, by the way, so don't have to worry about that. And let's see if I can access my front end over here. Let me try and open it in another browser window, and I will show you in a moment. Okay, so there we go, my fresh new install. Let's move to the next step, prerequisites. Everything looks great. I think I'm not only going to get my server running, I'm also about to get my front end running, right? Database port 5432, I specified it explicitly. Schema public username Zabbix, password Zabbix. Can we connect to the database via TLS? One of the questions in the Q&A section. As you can see, yes, we can. Database type Postgres, and ever connecting to the database. So what's wrong over here, guys? Everything seems fine, but let's take a moment. So the cause of this problem is the wrong authentication configuration found over here. We have actually specified ident config from all of the remote connections over here, but what we need to specify is that for Zabbix user on Zabbix database, we are using MD5. So that's what the front end uses. Let's see what else is going on. Let's see, we have some questions. Comment from a colleague of mine: you don't have to change to empty. Just host connection was not allowed for a particular user. Yes, you are talking about the DB host, I think, if I'm not mistaken. And yes, that can be restricted via these here connection settings. This is where we get to it, yeah. And we can actually over here restrict both the local connections to the database and remote connections via IPv4 or IPv6. We can restrict them to specific IP addresses, specific users, and so on. And specific types of authentication: peer, host, ident, MD5, or just trust every type of connection, which is kind of a general blanket setting. But right now, I will have to change this. So I will open my configuration. Let's take a look. var lib pgsql pg, let's see, data pghba.conf. And currently, yes, front end doesn't have access to this. So we will change it. We will make it a bit more stricter. We won't allow connection to all databases, just Zabbix database, Zabbix user, and we will use, let's see, we will use peer over here, if I'm not mistaken, MD5, sorry, yeah, password, MD5. All right, we will save this. We will try and restart PostgreSQL. Typo. And let's try open up our front end and let's reconnect. Let me find my front end and let's see. And success. So we needed to enable authentication via MD5, either for a specific subset of connections, or in this case, specifically from my loopback address on my Zabbix database for Zabbix user. All right. Maybe a minute for you to catch up with this, because we do have our instance running. Workshop instance, default time zone, default theme, couple of new things, by the way, in 5.2, summary, and we are finished. I can log in and see everything running in Postgres. So once again, this was a completely fresh install of Postgres. My database was pre-installed with default settings. Yeah, just looking at the questions right now, I'll answer them in a moment. And my Zabbix server was pretty much just going by the guidelines, of course, with the exception of the changes in hba.conf, which I just made. So backend was connected via socket to database, but frontend by localhost. Yes, that is correct. That is correct, yes. backend by socket, frontend by localhost. Let's see. So if you're trying to catch up, I will give you a minute to catch up. And let me maybe try and see what's going on in the chat. What is PHP FPM? That is the PHP process manager that we are currently using in some of our latest releases. An alternative of PHP Fast CGI. Will I be covering timescale DB extension? No, I'll be covering general Postgres tuning in a moment for Zabbix. Maybe some of those things also apply to timescale, but I won't be covering timescale specifically. All right. I think hopefully you guys have caught up, and let's take a look at the next steps. Let's break our instance even more in a moment. So we have kind of tuned Zabbix for Postgres, but we haven't really done much Postgres tuning for Zabbix. So we have to kind of flip things around now. And we will see how Postgres needs to be tuned to accommodate your Zabbix needs. So, of course, as many of you probably know, once we spin up our instance, we need to do some initial tuning of Zabbix, pollers, bingers, trappers, essentially gathering and internal processes, for example, history syncers, that's DB syncers over here. They need to be tuned. But how do we accommodate this, and do we need to accommodate this from the Postgres side of things? Well, we actually do. If we raise our pollers to 200, so over here, you may see something like this. Remaining connection slots are reserved for non-application super user connections, and we are unable to connect to the database. Let's see this in action. So 200 pollers really isn't that much on a medium-sized to large-sized instance. Let me quickly switch over to that. Let's see zabbixserver.conf. Let's take a look at our pollers. So I just have 5 currently. I'm going to raise this to 200 out of 1,000. So once again, just 1/5 of what's permitted. It's not too much. It's much, but it's nothing crazy. We see this quite often. Systemctl restart Zabbix server. Remember, we need to perform a restart to apply configuration changes. And let's see if we can get this running. Var log Zabbix server log. And we can see failures. So just as in my slides, I raised my polar limit to 200, and all of a sudden I'm seeing failures over here. If I do psaux grep Zabbix, you can actually see I have 200 polars up, but I'm not able to connect to the database. And why is that? So counterintuitively, as maybe some more advanced users know, yes, DB syncers, the history syncers, they do flush your metrics from caches to the database. So of course they do need database connection. But we have a limited amount of them, most likely, something like 4 or 6 or 7, not 200 or 100, because by default, by the way, that connection limit on Postgres is 100. Well, the reality of things is that pollers, they also do connect to the database. Yep, they connect to the database to update some item statuses and things like that. And this will, by the way, be fixed in the coming versions. So right now, we need to take into account that we have something like 204 processes, maybe a little extra, maybe there's something that I'm forgetting, but something around low 200s connecting to the database. And we need to, here we have, by the way, I have pointed out a ZBX next, where this issue will be fixed. You can follow this. Should be fixed in 5.4. And of course, what I forgot the web backend. We also have our web backend each session, connecting to the database. So it's actually not low 200s currently, something like 250-ish connections to the database. So of course, we have reached that limit, and that's why we cannot communicate with it properly. So we need to increase this. So let me open my configuration of Postgres. Let me see. And it's going to be .conf, PostgreSQL.conf. Let's look at max connections. And I'm going to change it to 300. Save it. And do a systemctl restart PostgreSQL. Okay, and let's take a look at our server log. Connection terminated probably because of the restart. Let's just restart our Zabbix server also, though I think it will recover on its own after a while. But we are on a time limit, systemctl. We're on a time limit over here. And we can see, we have 228 processes started, no error messages. So a very kind of small initial tuning that we did that is mandatory on medium-sized instances already. So we have our server working. Great. And let's see, maybe we have some other questions. I think someone already was guessing that, it's the connection limit on the DB. Yes, that's correct. Let's see, is there any way to lower CPU usage, let's see, during night hours, or to disable gathering items during the night? Is it possible to do it in an easy way? Well, actually, you can do it natively within Zabbix. You can create a flexible update period, a custom flexible update period. If you just hit it in Google or our documentation, you will see you can essentially say that, hey, I wish for these specific items to gather data only during specific days and specific hours, say only working days from 9 to 6. And outside of that, I don't want any data gathering to happen. So yes, you can do that. But and you can do that natively within Zabbix. But speaking about CPU load, of course, you need to make sure that your CPU load increase does come from this here thing, from metric collection, trend flushes, and things like that, instead of maybe someone hammering the front end during night hours. So you have to be kind of sure about that. Can we use PG Bouncer with Zabbix and Postgres? So as far as I have seen, though, I don't think it's documented anywhere officially, but you should be able to. Yes, I think I have seen some use cases with it being used. So yeah, you should be able to successfully use it, though. Yeah, there is no kind of official documentation on how to set that up. Let's see, what else do we have? Once again, if I'm wrong, my colleagues are free to correct me and answer these questions. Type the answers in, maybe in more detail. Should we consider further Postgres tuning for parameters such as work memory, shared buffers, etc.? Yes, we should, and this is what we'll be doing in a moment. So now that we have tuned our connections, we will now get to working memory, buffers, and we'll also look at vacuum. We'll look at out-of-vacuum parameters. So the common question is same about polders and different internal parameters and database parameters. How can we kind of automate the estimation of this? Well, we cannot really. It's very kind of environment specific. What's your front end load? What's your back end load? What kind of metrics you are storing? How often you are polling them? Your housekeeping periods and so on. So that all of that affects your performance. And unfortunately, the most precise results come from trial and error, which is good in a test environment, but won't really work in production. So I guess the good idea would be to simulate your Zabbix instance in a test environment. We can see some overlay over here, but no worry. I can explain this verbally. So a good estimate, and I have seen this used before, is third-party tools where you can kind of plug in your database version, your hardware specs, and this here, for example, pgtune tool, it will spit out a Postgres config that should be ready for your environment. And generally speaking, of course, maybe outside of max connections, which once again can be dynamic as you change and tweak your Zabbix processes and front-end users, the rest of the settings should be quite decent. Generally speaking, I'd say they are quite decent. So let's get to shared buffers and effective cache size and also huge pages. So generally speaking, and this kind of applies on larger sets of memory, so 16 gigs and upwards, shared buffer should be something like 25% of your RAM. If you're very limited on memory, then maybe 15%, but 25% is a good starting number. That's the data buffer for Postgres. This is where we want to keep as much data as possible, so we don't have to, address our hard drives or SSDs. Memory, of course, is a lot faster to work with data. Effective cache size. This is essentially the estimate of the free memory available to the operating system. And Postgres uses this for query planning, because it not only uses buffer, it also uses kind of OS level tools. And that's why it's important to specify this. Usually something like 50% of the RAM, but here this can vary by quite a bit. Another thing, by default, we have huge pages on try, on fresh installs. You can see this in my install when I open it. Huge pages try. So this means that Postgres will try and use huge pages, and if it fails, it will fall back to small pages. You can turn this on if you wish to make sure that your huge pages are enabled. But essentially, Postgres is kind of huge page ready. It works very well with huge pages when it comes to memory paging. There is a noticeable performance benefit. So step 1, enable huge pages on the OS level. Step 2, enable it in Postgres. Once again, in test environment, you can just try and turn it on, huge pages on, restart your Postgres instance. And if it doesn't crash, then that means we're using huge pages successfully, because with try, it won't crash if huge pages are turned off. Next up, working memory and maintenance working memory. So maintenance working memory is memory used by maintenance procedures, vacuums, index creation, table alters, and so on. And when does this happen? This happens mostly, well, except of the vacuum, this happens mostly during upgrades. So this should be quite tuned for the upgrades. We should have kind of as much as working memory as we can afford, at least temporarily during the upgrade. But if we have regular vacuums, which we'll cover in a moment, then of course we should also have memory allocated to this. Working memory. This is memory used for memory sorts or for sort procedures. And essentially, we can, well, this is a very general estimate, but we can have a single sort procedure per a connection. So if our working memory is a couple of megabytes, it will actually take max connections times working memory. And this is our ceiling that the working memory can potentially reach. So be careful. Even if you set working memory to a couple of megabytes, it will be multiplied potentially by 300 in our case. if we do a lot of sorts on each of the process. Then next up, let's talk about parallel processes and worker processes. So concurrency, max worker processes, the maximum amount of worker processes for both maintenance tasks and parallel queries. Then we limit this with maximum parallel workers, maximum workers for parallel operations. It's kind of a subset of the max worker process. Max parallel workers per gather is essentially parallel workers per a single query. And max parallel maintenance workers is the subset of the max worker processes for maintenance. Usually, the general rule is the max worker processes and max parallel workers is usually the count of CPU cores. And then we limit the workers per gather and maintenance workers to a half or 1/4 of our CPU cores. If we have something like 24 cores, I'd say 4 workers per each will be fine, because we don't want, to allocate all of our kind of workers to a single large query or large maintenance task. That's why we need to limit these. Otherwise, all of the other performance will suffer. And next up, vacuuming. So quite often we receive questions. So we do have housekeeping. It cleans up the data, but the database size is still extremely large. That's because the dead tuples, they still remain, and we need to remove them via vacuum. Essentially, you have a lot of unclaimed space in your table with all of those dead tuples in your tables. So by default, in the newer versions at least, the auto vacuum should be on, or you can manually execute it. And there is quite an elaborate logic on how this cleanup works. Essentially, we assign a cost, a performance cost, to memory page hits, memory page misses, and when a page gets cleaned up or dirtied, so updated or cleaned up. And depending on what kind of operation do we execute, what kind of page do we hit, miss, or clean up during this vacuum, we will this operation will have a cost. And once we reach the cost limit, which is 30,000 in this case, and this depends on the performance, by the way, the better the performance, the higher the limit you can probably have, we will wait for 20 milliseconds, which is the delay over here, and then we'll execute the next vacuum. Then we also have the vacuum threshold. After how many kind of dead records timed by fraction of our total records, which is the scale factor over here. So sum 50 with the 0.01 of your total records. After we have this many records that should be cleaned up, we will execute auto vacuum by 6 workers. So 6 vacuum processes in parallel can do cleanup. But this cost is split among them, by the way. So you can kind of divide it by 6. Once again, the better the performance, the better hardware you have, CPUs, SSDs, the more parallel vacuum workers we can have, the higher our vacuum limit when it comes to the cost can be, and the faster we'll clean up our database. Of course, this is of concern only if we have a really, really large instance, but we have done some vacuum tuning where it has been slow on really, really large instances. So if your vacuum is slow and has a pretty noticeable performance impact at runtime, if doing backup hours or maintenance hours is not an option for you, then you have to take a look at these here parameters and try and find a kind of an optimal approach to this. And once again, it will be different in every environment. You can play around with the cost limit, number of workers. These here costs usually are fine. These here costs over here, which you can do also. You can increase the vacuum threshold to say 3,000 and reduce the scale factor to 0, so there's no kind of complex math going on. You can just say, hey, once we have 3,000 dead records that need to be cleaned up, execute a vacuum. That's a simple way to do it. Or you can sum 50 with the fraction of your total count of records. So to summarize about the vacuum, as I said, the cost limit is global, 3,000. It applies per worker. Each worker gets, only 1 divided by the count of workers of the total cost limit. And an easy way to improve your vacuum performance, if your kind of hardware performance allows it, is to increase the cost limit, this here parameter over here. Once again, if your hardware does allow it. And that's pretty much it. We covered basic install. We covered some parameters from the Zabbix side, cleanup, memory, buffers, and you can always follow these here slides to take a look at these general parameters. Of course, this wasn't everything. There are quite a few more parameters that you can tune and tweak, but this was a general look on how you can customize your environment for Postgres and how that correlates at some points to Zabbix performance, and how it correlates to Zabbix parameters, both during the install and at runtime. So let me take a quick look at the Q&A, and then we can actually have a global kind of Q&A if there are some questions that maybe others can answer. So since Postgres 12, we decreased the auto vacuum cost delay. So let me see. Auto vacuum cost delay from 20 milliseconds to 2 milliseconds. So once we hit the cost limit, we will wait for 2 milliseconds in your case. Once again, if your performance allows it, then yeah, sure, I don't see a problem with it. All right, so I hope you guys enjoyed the event. We can see some buzz already going on in the chat, in the Q&A. Presentations will be available online, so don't worry about that. We will maybe have some blog posts in the future about these topics, now that we have all of this knowledge from Postgres professional guys over here, and we're sharing this together. So maybe some information and improvements also to the Postgres Go plugin coming in the future. And yeah, have fun with timescale, with Postgres, with monitoring it via the Go plugin or any other way. ODBC maybe, user parameters, tons of approaches. That's what Zabbix is there for. And keep an eye out on the Meetup schedule. This is the last this year, but it is definitely not the last ever. So keep an eye out. Maybe we'll be covering some other very interesting topics. So thank you guys. Have a great rest of the day and have fun with Zabbix and Postgres.